Welcome to Chemistry Simplified. Our topic for today is the periodic table. So we're going to take a brief overview of the periodic table so that we have a better understanding of it, because in chemistry, unless you have a full understanding of the periodic table, you will not understand exactly how everything works out. So let's do that. So this is a copy of the periodic table. As you can see, you see many symbols and numbers. So we're going to go over an example to make sure that you understand what's happening. So let's see, if we were to pick this letter here, letter O, right? So let's look over it to see what we have going on here. So this is the symbol, the chemical symbol O, and this represents oxygen. That is the element's name. The bottom number 15.999 is the atomic weight, whereas the top number, which is 8, is the atomic number. Now let's take a look at the groups, the group A elements. So we have group 1A, which include hydrogen, helium, sodium, potassium, and so forth. Group 2A elements include beryllium, magnesium, and so forth. We go across the periodic table. Group 3A include boron, aluminum, gallium. Group 4A include carbon, silicon, and so forth. Group 5A, nitrogen, phosphorus. Group 6A, oxygen, which we just looked over a few minutes ago, sulfur. Group 7A, fluorine, chlorine, bromine, and so forth. And lastly, group 8A include helium, neon, argon, krypton, and so forth. Now let's shift our attention to the period. So we have period 1, which extends from hydrogen to helium. Period 2. Period 3, we have sodium, magnesium. Period 4, potassium, calcium. Period 5. Period 6. And lastly, we have period 7. So the word period also means energy level. When we go over electron configuration in a later lecture, we'll talk more about the energy level. Alright, so let's move forward to talk about the names for the group A elements. The group 1A I refer to as alkaline metals. Group 2A, they are called alkaline earth metals. Group 6A are referred to as chalcogen. Group 7A are called halogen. And lastly, group 8A are called the noble gases. Let's look at some of the characteristics of the group A elements. Group 1A, normally if they have any charge, it would be a positive 1 charge. Group 2A, positive 2 charge. Aluminum, positive 3 charge. Carbon, if it has a charge, it might be a negative 4 charge. And nitrogen, phosphorus, and arsenic, most of the time, if they're going to have a charge, it's going to be a negative 3. Now, having said all this, the charge can be different, but most of the time, usually if it's located on the right side when it's reacting with another element, it will be those charges. That's what we're trying to say here. Group 6A, negative 2 charge. Like we said earlier, there could be exceptions to the rule because oxygen sometimes could have a negative 1 charge and negative 1/2 charge, which we will cover in some other lectures. And group 7A, normally, if they're going to have a charge, most of the time it would be negative 1 charge. And group 8A, the noble gases, they have no charges. The reason for that is because they are stable. And we're going to learn that most of the other elements, they assume those charges to become stable, to have an electronic configuration that is identical to that of the noble gases. That's why they would have those charges that we just talked about. Let's classify so we have these metals. So these are the metals. Here we have the semi-metals or metalloids. And lastly, we have the non-metals. Next, we have the transition metals. This is group 3B, 4B, 5B, 6B, 7B, 8B, 1B, and 2B. Now, the transition metals, when they take charges, their charge could be different at times. For instance, iron could have a positive 3 charge or positive 2 charge. It all depends on what it's reacting with. Whereas copper sometimes can have a positive 1 charge or a positive 2 charge. Other transition metals such as zinc, cadmium, their charges do not change. Most of the time, zinc has a positive 2 charge and cadmium have a positive 2 charge as well. The metal from number 57 to 71 are referred to as lanthanide, whereas those from 89 to 103 are referred to as actinides. Next, let's talk about hydrogen and helium. Sometimes you may see hydrogen located on the far right upper corner of the table next to helium, like we have it here. In these instances, hydrogen behave like group 7, one of the halogens, like fluorine or chlorine and bromine and iodine, because it would assume a negative 1 charge. This happens when hydrogen reacts with a metal. So in this situation, they would refer to hydrogen as a hydride. Lastly, helium could be located on the upper left corner next to hydrogen on the other side. The reason for this is that when we do electronic configuration, helium has a configuration of 1s2. So it assumes a configuration just like the group 2a element. So at times you may see it next to hydrogen because of that. Let's do a couple questions so we can finish. So question number 1, which element is located in group 4a in period 2? And the answer would be carbon. Let's take a look at the periodic table. So we look at the group number, group 4a, and period 2. The intersection between them is carbon. So the answer to our question is carbon. Next and last question, which element is located in group 7a in period 4? And the answer is bromine. Let's take a look at the table. Group 7a and period 4, and bromine is the element that's located in the intersection between these two. Alright, that is all for today. I hope you found our presentation useful. Please remember to like, subscribe, and share.